Hello, my name is Stephan with Goulds Water Technology, and today we're going to cover a duplex operation with the e-HME or smart pump design. The smart pump design has a permanent magnet motor. So there's a couple of unique things about a permanent magnet motor. One, it is super efficient, so it is highly efficient motor design. Permanent magnet motors also require a drive. So with a permanent magnet motor, you have to have a drive like we can see here. The other thing about a permanent magnet motor, it is a synchronous motor. So what you're going to get is a little bit more performance out of a permanent magnet motor because more speed means more flow and more head. Really, there's always two steps with commissioning a duplex system. So the first thing that we'll cover is the wiring. So we can see we've got 4 screws here. We've already loosened them up, and we're just going to take the cover off. So we are going to be looking at just one unit here, and the other unit is going to be wired exactly the same. So we're going to start from left to right. So if we look at here, typical type of terminal board, we see the input power on the left-hand side. What's a little bit unique about this is we see a ground or terminal 1, one line terminal 2, and then a neutral terminal 3. Now the nameplate says 208 to 240 volt, 208 to 240 volt. And in this case here, we do have 240 coming in, regardless of the color. That's why we put some black tape to remind us that we do have 2 hots and a ground. So you simply connect one of the hots to line and then the other hot to what is at least labeled neutral here in this case, and we have a ground. So again, moving over from left to right, you see your relay, terminals 4 and 5. And next, you see a 15-volt supply. Again, we are not using that in this case. Terminals 7 and 8, not being used in this case. But now we see where we have to do some wiring. So this is terminal 9 and 10. P1 plus, P1 minus. And this is simply our sensor or transducer. So each unit has to have its own transducer. And so we can see here, typically our transducer cable is white and brown. We want to put the brown on the positive, terminal 9, and then the white on the negative, terminal 10. Moving on to the next 2 terminals, we see 11 and 12 and 13, 14. These are normally closed, and we can see that they come with a jumper. So basically closed means run, and if it was open, it would turn the drive off. The first terminal is just a start-stop, so if you want to control this with some other switch, simply closed means run, open means off. And the extra set of terminals here, 13 and 14, are really designed for a type of low water switch. Again, normally closed. When it's tripped, it's open, and it would turn the drive off. So in this case, we're not using any of these switches, so we're going to leave the jumpers in there. And the only other 2 wires that we need, we can see right here, terminal 15 and 16, and that is our communication port. So we have the exact same wiring on the other drive. We want to make sure that if we've got brown on terminal 15 for this drive, we want to have brown on terminal 15 on the other drive. And the same thing with the white. The white is on 16. Make sure it's on 16 for the other drive. We are not using the extra set of the communication port. As a matter of fact, you do need a separate module in order to use those terminals. So that's it in terms of the wiring. Simply input power right? Just remember that neutral, this is a 230, 240 volt motor, has to have 2 hots, transducer, and communication between the 2 drives. And that's it for the wiring. We've just finished the wiring for both units, exact same wiring for both, and we've put the cover on both of the units. So the next step would be to set up your keypad. So let's take a quick look at the keypad in the smart pump design. Very simple, and we can see here we have a minus and a plus button and a menu button. Across the board here, we are able to look at 2 different things. One is PSI and RPM. So we'll take a look at that. The one really nice thing about this drive is it's very simple to change the pressure. You don't have to go into any of the parameters. You simply just hit the plus or minus button to change your pressure. All right, so we'll just set it at 30, and as far as setting the pressure, that's all you have to do. All right, so what we're going to do today is just the bare basic menu setting for a duplex. So we're not going to go through every parameter, which you can look at in the manual, but we just want to get you going and get you up and running with a duplex. Now you can operate these as a triplex. We're just using a duplex for an example here today. So let's get into the parameters. So we're going to press and hold the menu button, and we can see that it starts with parameter P01. So a lot of the parameters in the beginning are just view type parameters. So let's go to the first one that you really need to make a change, and that is P20. P20, right, so now we got it to P20. You hit the menu button to get into it, and that's our password. So we have to put the standard default password in, which is 66, and that will allow us to get to parameter P21 and above. If you do not do this, it will not let you get past those other parameters, past 20. So you put the password in there, and you can see that it takes you to 21. And again, we're just going to go to the bare minimum for a duplex. So the next would be P25. All right, so P25. This is an important parameter when setting up your system. So let's take a look at some of the options here. So this is all in the manual, the installation manual, but sometimes it's a little tricky because the manual is going to say MSE, and we basically don't have enough room for an M, so this really stands for MSE. So M would be multi-pump, and SE would be Cascade serial. So let's just look at the options. Again, that's really stands for an M, multi-pump, and that's SY. That's synchronous. So we're going to take a look at both of those, and let's just keep going. ACT is actuator, that's speed control. And then your final option is HCS. So that is just simply for one pump. All right, so those are the options. So what you have to do is you have to decide, again, we got a duplex, so we have 2 options. We have multi-pump Cascade serial or multi-pump synchronous. Let's just look at synchronous in the beginning. Okay, so I'm going to set this to synchronous. Okay, now again, I'm going to do the same exact thing on drive 2. So what is the next parameter that we have to hit as a minimum to set this up? And that's going to be 55. So let's go all the way to 55. And 55 says your address, right? So one thing that we have to do is we have to identify pump 1 versus pump 2. So we'll call this pump 1. So we're good there. 56 is how many units do you have in your multi-pump system? And we have 2, so we're going to leave that. So really, those are the only 2 multi-pump type parameters, those last 2, in terms of address and how many pumps. So again, we have to do that for both units. So we're good with that. And if you want to go back to the main menu, I'm just going to press and hold. And it gets us out of the parameter view and back to the main menu. So that's it for programming or setting up your parameters. So we move to a bird's eye view so you can see, both units here in both keypads. So remember, we did the wiring for both units. We did the parameter setup for both units, and both are almost exactly the same. The only difference would be we have address 1 and address 2. That would be really the only difference in terms of your parameter setting. And how we left it was multi-pump synchronous. So on your display, it's going to show up as an N, as in Nancy, but it's really an M if you look up in the manual. So that's multi-pump, SY is synchronous. So synchronous basically means that when one pump cannot maintain the set pressure at full speed, it calls on the lag pump. And in this case here, this is going to be our lead, the one on the right, and the lag is the one on the left. Now we can change that alternation. The default is 24 hours, and we did not change that. So when pump 1 can't keep up, it calls on the lag pump to come on. And once that does, then they synchronize, meaning they operate at the same speed. So we're going to try to show you that here. And across the menu bar here is the default is PSI. And in order to change that to RPM, I'm going to hit the menu and plus button just so you can see speed across the top bar here on both. All right, so let's go ahead and open up the valve. So we've given it some demand. We can see our lead pump has turned on. And let's take a quick look at speed here. Again, menu plus button. See, it changes to 10 times RPM. Gives us a speed reference. And after a few seconds, it goes back to the default, which is PSI. So we'll just do that again. Take a look at speed. Open up the demand here. And the pump is speeding up to maintain that set pressure. And once it gets to full speed and cannot maintain that pressure, it's going to call for the second pump to come on. So we can see over here now, now we've got both pumps running. And let's just do a quick reference for speed here. And they're both full speed. So let me just dial it back a little bit so we can see that they're actually synchronized. Let's just look at speed again. So again, menu plus for both to change this view here to speed. And if we compare both, we can see that they're operating at the same speed. And so we know that they're operating in the synchronous mode. That was multi-pump synchronous. Your other option in a multi-pump operation, again, whether it's 2 pumps or 3 pumps, is to go with the MSE, serial cascade. So basically how that's going to work, and we'll set it up, we just have to go into one parameter, the P25 parameter. We'll change that to M, or again, it's an N here, NSE, and then we'll run it. But basically how it works is, again, let's think about the one on the right as your lead. And when it cannot keep up with the demand at full speed, it calls for your lag pump to come on. And what's different about this is your lead pump is going to operate at full speed, and then your lag is going to vary. So that would be the difference between synchronous and serial cascade. So let's go to the parameters here, and let's just change that one parameter. So press and hold again. So now we're into the parameters. So after a certain amount of time, we need to enter the password again. So just in case, let's do that again here. So let's go to 66. Allowing us to go to the additional parameters, and that's P25. So we can see that it was previously set or currently set at synchronous. Let's change, let's find Cascade serial Cascade, and that's this one right here. So just hit the menu button again to save that, and we'll get out of that parameter menu by pressing and holding. It gets us back to the main menu. So we just have to do the same thing over here. So press and hold gets us to the parameter. Let's go and just put our password in again just in case we need it. So that's 66. Allows us to go to parameters greater than P20. P25 again, and we just need to match them up. So there's actuator again, HCS, that would be your single pump, and here's our serial cascade. So press and hold, and now we're back to the main menu. So let's take a look and see if we can show you how that works. So we're going to give it some demand. So our lead pump hasn't changed because we have not hit the 24-hour time period for alternation. So our lead pump is keeping up with the demand. Let's just take a look at RPM again. It's not at full speed, it's maintaining the set pressure. So let's give it some more demand. Open up the valve. Take a look at speed again. Climbing, you can see the speed is increasing. Still seems to be keeping up with demand. You have a little bit more demand. So looks like we're at full speed over here. Unable to keep up with the demand. So now it turns the lag pump on. So let's see if we can dial it down to show you. Cascade serial cascade is we always have the lead is at full speed, and then the lag is the one that's going to vary. So we'll change to show you speed again here. So we can see the speed going down, right, while one was maintaining that speed. All right, let's see if we can show you that again. So we got full speed. We can't keep up with the demand. It turns the lag on. And your lag is going to be the pump that varies. You see pump 2 on now. Let's look at speed. And your lag is always going to be the one that turns off before your lead. We'll slowly crank that down. We can see the lag is turning off, and now we only need 1 unit. So that is your Cascade serial or serial Cascade. Again, it looks like NSE on both units. So that's really the difference. Synchronized, in this case, MSY. When both pumps are on, they're at the same speed. Serial Cascade, our lead is going to be at full speed and our lag is going to vary to maintain that set pressure. So those are your two options for multi-pump with your e-HME smart pump design. Thanks for watching our video today. For additional information, go to goulds.com.